Dear students, let us discuss about the X-ray diffraction technique. X-ray diffraction technique is a non-destructive analytical method for structural characterization of nanomaterials. So here what we do, we make X-rays to interact with crystalline materials based on the angle of diffraction of X-rays as well as the intensity of X-ray that comes out of these crystalline materials provides D-spacing or interplanar spacing of materials. What is D-spacing? D-spacing is nothing but the distance between two lattices in a molecule, which is unique to every molecule. So if you know the D-spacing, then you can identify what is the material it is. So XRD helps us to identify the D-spacing based on which we can identify the crystalline materials. XRD works on the principle of Bragg's law, where L lambda equal to 2d sin theta, where lambda indicates the monochromatic X-ray what you are using in the system, as well as then angle of diffraction, we measure it through the detector, then based on that we arrive at the D-spacing. Okay, so let us get into the instrumentation part of the XRD. So we have a X-ray tube which produces X-rays. Then I have an anode which produces monochromatic X-rays. Here the anode is a copper, so it produces monochromatic X-ray. Then we collimate through a slit, make them to hit over a sample holder here. Generally we use crystalline materials of the grain size less than 2 micron. Then we pack it tightly, then we keep it over the holder. Then other part we have a detector. Whatever the X-rays diffracted from the sample, then we detect over here. Okay, that's a basic instrumentation part. Let us look at the components what we have. As already mentioned, it's X-ray tube, sample holder, then detector. There is a very important mechanism that holds over here is goniometer. What is a goniometer? Which is a mechanism where it maintains the X-ray tube as well as detector at a particular angle. Okay, we have theta as well as theta to theta goniometer. Okay, so it's a very simple technique, non-destructive technique through which you can get the D-spacing, from which you get the what is the material it is by retrieving this diffraction pattern what we get in the ICCD database. Okay, so what you get out of this technique, you can find out the phase of the materials. Even you can measure the size of the crystallite that made up of the grain. The third one, even you can measure the stresses as well as strain over those materials. Okay, thank you very much.